Hello, hope you can hear me well. I'm Ito Zhu. I'm a current PhD student in finance, studying at People's Bank of China School of Finance, Tsinghua University. I want to present today about a study we've been doing under the guidance of Professor Peter Ye from UCL. The title of the project is The Triplet Dynamics of Carbon Emission, Economic Complexity, and Income Inequality under a global panel perspective. To introduce the motivation for our article, we want to start talking about energy and development. Now, it's quite the common sense that we need fossil fuels to boost our economy. We can't develop without fossil fuels. And literatures have recorded the link between energy consumption and economic growth. The problem is the co-movement of the growth and the carbon emission might not just be a causality, might be a correlation. There might be some other size of economic growth that dictates this dynamic, which is why we arrive at two measurements. One is the economic complexity index, proposed by the Growth Lab at Harvard University, which measure the complexity of an economy by diversity of the repertoire of its exports. The more diverse its exports, the more able the economy can produce different things, the more complex and robust an economy can be. It's a good measure for economic development because it describes how healthy the country distributes its resources in trying to industrialize, to adjust its industrial structures. Also, the income inequality might play a part in this. Why these two factors might be good measurements to dissect growth with? We have some literatures. Some have recorded that the classic environmental Kuznets curve describes how growth and environmental degradation are linked. At the very early stage of our growth or development, the environmental degradation is mild. But as you develop faster, your harm to the environment increases. And then it lowers again when you reach a mature status. Now, not every model records these kind of relationship, which, however, does make a lot of sense. This alone is not enough, though. Gini, which means a measure of income inequality, has some link with carbon emission as well. The question is, what kind of link? Is it positive or is it negative? The explanation for the theory that higher inequality leads to lower per person carbon emission is this. If you have a very unequal economy, then the poor might have no resources to consume at all. If they don't have resources, then the carbon emission distribution will be left skewed. They have nothing to consume at all, so no carbon to emit at all at the same time. And there are explanations for the other way around of relation as well. If you have an equal society, people optimize for their welfare. But if you have an unequal society, the poor will emulate what the rich do, and that leads to inefficient consumptions. Inefficient consumption of energies, inefficient consumptions, and ill consumerism culture, which means that it might lead to a worsen, on average, carbon emissions. This emulation effect is called Veblen effect, and we think that inequality can lead to higher carbon emission. Now, our model expected to contribute in a way. Firstly, it's a model that consists of 116 economies over 5 decades, which is a scale unachieved before. If we can study the dynamic of income inequality, ECI, and carbon emission in these samples, we believe we can uncover something that helps the policymakers to rethink the development strategies. And we have some conclusions that point to that these dynamics matters. Now, about the data and model we used in this project. we can resort to World Bank's database for many variables: carbon emissions, Gini index, GDP, population, income group, etc. The problem occurs with the Gini index because it's the major source of unbalancedness of our panel data. To help with that, we resort to different sources, and we calculate inequality measures as a Gini index surrogate to use in our models, and reduces the problem. Now again, if we look at the descriptive data, we can look at the first how per person GDP links with per person emission. You can see income groups kind of dictates how emission goes, but this might just be a correlation. It's very clear, but it might be deceiving. If you look at the specific link between carbon emissions and GDP, you can see some just don't go in pace. Asia have booming economy, but the carbon emission does not go along with it. Europe and Central Asia areas have very good economic development, but the carbon does not go along either. Now, Middle East and North America does not have that kind of income jump, but the carbon just goes up and up. Now, North America just have 3 samples, so it's not very representative, but you can see as well, it is just not what we think it is. It's not just a simple positive correlation. Now, if we look at the bar charts of these data, you can see that there is a inverted U shape of carbon emissions for North America, for Europe, but an increasing income. Now, for Asia and Pacific areas, they have an increasing carbon emissions and increasing income overall, but not every country does the same. If you look at the Middle East and North Africa, it has an increasing carbon emission, but it doesn't seem like what's happening with the income, at least not that proportionally. If you look at ratios, you have the same conclusions. So what dictates this? That's why we use our models to study the dynamics. Now this is a simple descriptive statistics, which I want to skip. Now, we use a panel model. We use fixed effects models, which preserves the consistency of estimators. Have random effect models. We have auxiliary models because we want to verify that sometimes missing the variables can have what you want. If you miss the Gini and you miss the quadratic terms for ECI, you can still get what you want, but you are missing some important explanations. And you want to say growth, it matters to carbon emissions, but it might not be the entire truth. Also, we did the clustering analysis because we have 5 decades for 116 economies. We want to identify whether these countries would have different development routes. So if you think we can plot the data average of every 10 years on this kind of plane where we have x-axis as Gini and the y-axis as ECI, and we plot the points with the size being the per person carbon emission, you can find a graph for each of the 5 decades, 5 phases. And you can see whether, after clustering analysis, countries stick together for the entire 5 decades or they jump between groups. If they jump between groups, it might suggest that they are switching their development tracks. They are in a different group, they perform well, they outperform their peers, or underperform their peers. It will help us identify whether countries select any kind of strategies to improve ECI at all, or reduce Gini at all, or just keep staying at where they are. Now, the main model suggests, as we have anticipated, ECI will reduce carbon emissions. Now, if you don't have Gini or ECI, at least not enough terms of ECI, you still have that growth would boost the carbon emissions. But it's not the entire story. If you include the Gini in there, you don't have it anymore. It's not significant, which means that Gini have a bad effect on carbon emissions. The more unequal, the more carbon emitted. The better your economic diversity, the lower your carbon emissions. These 2 terms can explain how carbon emission changes thoroughly. You don't even need growth. That's the result of our main models. And then we proceed into our clustering analysis to see if there's any development tracks. Now we have concluded that this relation generally exists. Does that affect how countries develop throughout the decades? If you can see roughly, for the last 15 years, countries have located this way. Now some locate in the fourth quadrant on this Gini ECA plane, where they have very low economic complexity but very high income inequality. They have relatively higher carbon emissions compared to, some of its peers, because it has specifically higher numbers in some of the statistics. Suppose it have a better economic growth or economic conditions, it would jump towards these kind of second quadrant where diversity is high but inequality is low. Now you can see this more clearly with a graph that depicts the change throughout the 5 decades. You can see some countries tries to go up there to have a higher diversity, to endow their economy with chances to be more robust, to be more diversified, and then move to there. Now some of the examples move directly to second quadrant as well. You can see Japan starts here and moves there. Israel, China, these countries succeeded in moving towards the second or maybe the first quadrant. We'll explain what does it mean to move into first quadrant later. But the thing is, if you can escape fourth quadrant, you escape poverty trap. Otherwise, you're being trapped by your endowment. Now, the clustering analysis suggests that at first, you can see Europeans have the best development, so they are a single group. Other world just stick together there. The United States is usually very strange because it has very high carbon emission per person. Now, some countries that has heavy uses on fossil fuels will stay with themselves. That's how the first decade looks like. And from 1976 to 1985, some countries were striving to join the second quadrant. Jordan, South Korea, Singapore, Mexico even, Portugal, Argentina. Europe still stick together. But you can see at that time China has a very good equality status, so it has a very low carbon emission as well. But the next decade is a bit different. You can see that many of the developing world stick together again. Mexico dropped back to this group. Argentina dropped back. Jordan dropped back. Some still maintains the middle tier status, like Russian, Singapore. Some of the Asian rising economies join the Europe zone. Say Europe group, sorry. They have a higher economic diversity and a lower inequality problem. So you can see Japan, South Korea, Hong Kong, and these economies have achieved what the European economies has done. Now, some others stay there. The fossil fuel heavy countries also still have the higher carbon emissions. You can see that compared to their middle tier, they have relatively lower carbon emissions. Now, if you proceed into the later years, things start to stagnate. Some stick together, but roughly there's just two groups. The developing world cannot jump out of their poverty trap, so to speak. Not every country here is in poverty, but they cannot escape these nevertheless. Now, the last decade suggests that firstly Europe, Japan, Singapore, Israel stick together, and there are some middle tier economies that is joining gradually towards the first quadrant, towards America, so to speak. It is still unique by itself, but roughly you can see that the developing economies succeeded very rarely in joining the second quadrant, while some still stays in the middle. Russia, Australia, Canada. But overall, countries tries to go to the first quadrant or just directly to second quadrant, finally trying to be part of the first quadrant, at least on intersection of the two quadrants. If they failed, they stay here. Some succeeded in maintaining a low inequality problem, but they cannot rise the diversity of their economy, which means they cannot escape their current status, and they can't reduce carbon emission that much, at least not without sacrificing part of the economy. Now, some of the Asian economies have displayed promising characteristics. They're joining, more often than not the first quadrant rather than the second, but they're getting close to the European economies. Some tries to escape the poverty trap, but failed. Argentina, Brazil, India, Philippines, they try to they diversify the economy with very good equality status in their economy, but it just can't be achieved. But if they do, they can reduce the carbon emission at the same time. Now, one particular good example is Israel. It achieves a high economic diversity, a low economic inequality, and also it succeeded in reducing the carbon emissions overall. Now, this is an example to learn from. For conclusions, we have seen that these dynamics can help explain how countries move from